This is the Geek Out, the second part of the Geek Out R series. You don't need to have been at the first one, so don't worry. I'll cover the same stuff. So to start off, if everyone could open RStudio on their computer, that's this program, in case you don't know. And it's not going to look like this. Don't worry about that.
How do you do that?
Are you on the school computer?
Yeah.
You can search down here.
Okay.
And just search RStudio.
Okay.
Okay, does everyone have it open? Okay, cool. So what RStudio is, in case you don't know, it's what's called an integrated development environment. It's essentially a way to write code in R, see the results. You'll see the results over here. And then also see the sort of like the variables in the different tables that you have stored up here. So these are like the files that you have in your current working directory. None of you will have anything there probably. This is where you can see plots, where you can see graphs and stuff. Let's see if I can make this better. Packages, where you'll see the packages that you have loaded. Help is where you can get help on different packages and functions and stuff. So what I want everyone to do first is go to File, then New Project. You won't see this. File, New Project, New Directory, New Project, and then create a new directory called Geek Out 2018 or something. And then hit Create Project. Okay, so you should see, does everyone see a window like this? Cool. So what you just did is you created a new folder called Geek Out 2018. That'll be the folder that holds all of your files. It will be your working directory. It'll be where you save everything. It's a very easy way to keep track of everything that you're doing. And you can see the current stuff that you have saved down here. You should probably only see our history in Geek Out 2018 project. These are stuff from the last time. Okay, so next what I want you to do is go to New File, File, New File, our script. So down here is your console. You can code down here, but it won't save anything. So none of this stuff that I code down here will be saved. But if you come up here, don't click that. If you come up here and use code in the script, you can save that as essentially like a text file or a document. So save this. You can save it just by Control S or save. Call it Geek Out script, and then hit save, and you'll see it down here in the files. And this isn't auto-save, so every once in a while when you're coding, just make sure you save this. Everyone have that? Good. Okay, so next what we're going to do is going to install and load a couple of packages. And what packages are, they're essentially just customization options for R. They're built by a user out there, and they make it easier to use R. Base R, like the programming language itself, is a little bit clunky, but people have written things that make it way easier to do stuff and to make cool visualizations. So to install packages, you do install on packages. Tidyverse is the first one we're doing. Installed on packages. Gapminder is the second one. Gapminder is a data set that we're going to be using. And then one more. Installed on packages. GG themes are cool themes for graphing that make your graphs look cool. Like you can make it look like a Wall Street Journal graph or a 538 graph. So once you have all this written, you can highlight this and then click Run. If it works, yeah. And installing Tidyverse might pop up a dialog window down here. If you click on that and then it has like an option, you can just hit no, and it'll install as normal. So again, let's highlight this and then click run up here. Or if you want to do a shortcut, you can highlight and then click, and then press Control plus Enter. That will also do the same thing. And you make sure you have these in quotes, the package names, either single or double, it doesn't matter. Yeah.
Once we type this, we click run.
Yes. You highlight it and then you click run. And again, it might, like Tidyverse installation might pop a dialog window that will show up down here. If you click on it and then select no from the option, it'll install as normal. Yeah.
What if you didn't highlight it?
I don't think it'll, I actually don't know. It might run. Did it run?
It'll only
What
run
about
that.
It'll only run that one. So if you can just do it again. You can just highlight it, click run.
So I got that dialog box and I still clicked yes, and it's still loading,
That's fine. It'll take a while.
but it should still do the same thing.
Yeah, I think so. I think it shouldn't be an issue. Let me know if it doesn't resolve in a minute or two. Tidyverse is a huge package that takes a while because it's a collection of like a dozen different user-created packages. Tidyverse does a lot. It has a lot of different things associated with it. I'm not even sure what's all that's in it, but it does a lot of things to make R way more usable. Yeah.
So the script file that we saved is part of the Geek Out project file?
Yes, that'll be saved in the folder, in the Geek Out folder. Okay. Does everyone see this little arrow down here in the console? That means that it's done. If you don't. You don't see that? Do you want Anyone else not see that? Yeah. Oh, this is the dial. Yeah. Oh, this is a. That's fine. I think it's. Yeah, you're good.
So where was it hidden under the taskbar?
It was just on there next to the R button right there. Anyone else having trouble? If you're not seeing this yet, if you're not seeing it install, there might be a pop-up box that shows up right next to the R icon on the taskbar down here. Just click it and select no or yes. It doesn't really matter apparently. Okay. Does everyone see this arrow right here down in the console? Is it still installing? Okay. Yeah, that's fine. It takes a while. It's a massive package.
Okay.
While that's installing, we're gonna write the next 3 lines that we need. So after you install, you need to load the packages, which you do by writing library and then the package name. And make sure that the names in this one in the library are not in quotes. And then hit run once you highlight them. And don't worry about the warning messages if you get them. So every time you open a new script, or every time you reopen R, you're going to need to run these 3 lines. This is how you load the packages for use. You don't have to run the install packages every time, because those will be installed once, then you're set to use them. You do need to run these library lines every single time you open R.
I got an error on one of mine.
What does it say?
Error, package or namespace load failed for GG themes and load NA or load namespace.
Yeah, it's like the same thing. GG.
I think I just tried to.
How did you go to variable? How did you skip before?
Just click on the type percent. Can you install 2%? Put down the first line. Yeah, just the first one? Yeah.
I'm trying just to open it new one.
Yeah, try that.
Just want to make sure.
Same thing.
Ah, it's the same. So it's fine to get rid of
Yes, it's
Okay. Yeah.
Excuse me.
Yes.
I don't know why it disappeared. Did you say I didn't again?
Uh,
Oh.
install you clicked yes on the demo box. Okay, so I must have not installed stream. Okay, everyone else is good. If you're getting error, is anyone else getting error messages? Not these warnings, but errors. Okay, we're all good. Cool. Okay. Once we have those packages loaded, we can actually start playing with the data. So Gapminder is essentially a play data set that contains a bunch of information from countries throughout the world, including like GDP, population, life expectancy. It's a fun data set to play around with because it's pretty clear cut. Yeah.
Is there a reason why you are skipping one number?
One line.
Yeah, one line.
It doesn't do anything. It's just readability. I like to keep like chunks of code separate. It doesn't. You can do it or you can not. It doesn't matter. Okay, so what we're gonna run is gmdf Gapminder, and then click run, and you should see an object over here. So what this does is it takes the data from Gapminder. This arrow is an assignment. If you've done any other coding in like Python or something, it's the same thing as one equal sign. It's an assignment, so essentially you're taking Gapminder and you're assigning it to the variable named gm_df. This is a variable.
And it's a variable representing what? It's like all variables are gm_df. It's a variable but representing what?
So it's just I just came up with this name. It's just a name for a variable. Yeah, but it's, when you run this line, everything that's in the Gapminder dataset is assigned to the variable that I named, gm_df. So I could just as easily do like geek out var. It's the same thing. It's just a variable. But we'll do gm_df because it's Gapminder data frame. So this variable over here is now a data frame And you can think of a data frame just like an Excel spreadsheet. So it has a bunch of columns and a bunch of rows. You can see that it has 1,700 rows or observations. It'll say 6 variables, I think.
What do people do if they want to take notes, Alex?
Oh yeah, you can take notes in this script. Thank you, Caitlin. By commenting it. So if you want to write a comment, you can do # and then write something. And anything on this line won't be run. So this is just a comment if you want to remind yourself how something works. Okay, is everyone good? Cool. So, since GMDF is now a data frame, which means it's essentially a spreadsheet, we should explore what that data actually is. What are we seeing here? So the best way to do that is, so you can do several things. You can do GMDF and just run that, which will give you the first few lines. But that doesn't tell you much. It doesn't tell you what is actually contained within the data set. It just gives you the first 10 lines. So you can also do is glimpse GMDF and then run that, which will give you a sort of quick glimpse of the different variables, the different columns in the data frame. So we've got country name, we've got continent name, we've got the year, we've got the life expectancy, we've got population, and we've got GDP per capita. So this bit right here indicates what type of variable it is. FCT is factor. You don't need to worry about that right now. Int is integer. DBL is double, meaning it's a decimal number. So yeah, you also see sometimes like vec for vector. There's other stuff that you'll learn as you get deeper into R. For the moment though, all you need to see is like, these are the 6 variables that are in the data frame. If we want to see quick summary statistics, if we just want to see like, what's the mean of certain columns, how many observations, unique observations are in each, you can do summary GMDF. And this is great because you can actually see things like, okay, Afghanistan has 12 observations. There are 624 observations in the Africa continent because, each country has multiple observations. The data set starts in 1952 and ends in 2007. Life expectancy, the minimum is 2360, maximum is 8260. Any questions on that so far? Cool. Okay, so so that's the first thing that you'll do when you're starting to play with a new data set is just see what's in there. Just see the sort of, data that you're dealing with. Next, some of the stuff that you might want to do is say, select only 2 columns, or select 1 column. Because when you have an enormous data set, like say you're working with the global terrorism database, using the entire spreadsheet all the time is incredibly slow and takes a lot of memory. So if you want to only select 1 column to work with, then you'll write this. Okay, so breaking down what this does. GMDF is your spreadsheet, your data frame. This is called the pipe. What it does is essentially it takes this and it does this to this. So you can read pipe as then. So GMDF then select country. And then select selects a certain column or a number of columns. So if you run that, you'll see that you just selected the country column. So an important note about this is these 2 lines right here don't assign anything. They aren't saved. You just see them in the console. It's just for practice, or it's just for viewing purposes. If you wanted to make this a new data frame or a new list, and if you wanted to save just the country column to its own thing, its own variable, then you would do country call, arrow, GMDF, pipe. These are called the pipes, and then select. So, yeah.
Can you select more than one variable? So
Yes.
select country, comma, GDP, or?
Yep. If you wanted to do that, then you could just do, I think this works. Yeah, so you'll get 2 columns. So for our purposes, since we don't need to save a lot of this stuff, I'm just gonna run these so you see it done in the console. We don't need to keep saving variables, but that's how you would do it if you did want to save. You would write that. So what it's doing is it's taking these 2 lines, doing them, and then assigning them to the new variable country underscore call. Does that make sense? And this is just a name that I came up with. I'm just writing a column, so it's not clear. If you wanted to select a range of columns, then you can do this. This is using the index, which is essentially the number, like if you list out the spreadsheet, then the first column that you see is 1, the last one is however many columns there are. So this is selecting from the second column through the 4th column. So if you run this, then you'll see that it's selected the continent, the year, and the life expectancy columns.
And I can always see the names of the columns from the other part, from the data. I would click
Yeah.
and see.
Yeah, if you want to see the whole spreadsheet, you can just click on it over here, and it'll open. The only thing I would say about that is if you have a massive spreadsheet with like millions of observations, then it's going to take forever to load fully like this. So oftentimes it's easier to just look at it in the console, which is down here. It will take less time if you have a massive table. Okay, so if we wanted to, say, filter the data so that it only retains the data from Asia, we can do that with a command called filter. So gmdf pipes filter, and then the continent's column name is called continent. Continent equals Asia. Oops, I meant double equals. So for those who haven't done any programming before, the double equals sign is a comparison. It means is the left side equal to the right side? If yes, do whatever the command says. So this is taking the entire data frame and then filtering the rows so that it only retains the ones where the continent column is equal to Asia. And you can see that there are 396 rows in the Asia column.
And I'm doing these quotation marks in case it's a name. So if I want a number, I just list the number equals 1.
Yeah, that's a good point. If the thing that you're filtering on is a word, then you have to put it in quotes. If it's a number, then you can just say, like, if you want to filter on the years such that the year is equal to 1992, you can just do that. You don't have to put in quotes. Yeah.
What did you say again? The double equal is
The double equal is a comparison.
the comparison.
So the single equal or the arrow is an assignment.
Okay.
The double equals is a comparison. You can also do things like compare against a list. So if you want to filter so that you only see the countries from, say, Scandinavia, you can do country in Okay, so what this is doing is it's taking the country column and then it's seeing if the country column, the value in the country column is equal to anything in this list. This C means combine. So it's combining this whole thing into a single list that it's comparing against. Does that make sense? Okay, so say that you want a new column that is, so since our column is GDP per capita, what if you wanted GDP? So the way you get that, GDP, if you have GDP per capita and you have a column that's population, you multiply GDP per capita by the population. So if we want to just get, if we want to get the GDP of each country, then what we can do is called mutate. And this creates a new column. So mutate GDP equal to GDP per cap times pop. And since this is an assignment, you're using 1 equal sign. Oops. And we might actually want to do something with this later. So let's save this column. And to do that, you assign these two lines to the spreadsheet. So essentially you're overwriting this variable GMDF with all of this. This just allows us to use the GDP column later on. Any questions so far?
So if the function before, which is the filter, the program applies functions continuously, like
Yeah.
I filter, then whatever the next function is only based on the filter.
Exactly. Yeah, so that's a good point. So going back up to this filter line, you can chain functions together by doing multiple pipes. So if you wanted to say filter all Scandinavian countries and then filter on the year 1992, then you can add another pipe here and then do another filter command. So it processes these in sequential order.
And in case I just wanted to return back to the whole set of information and delete the filter, if I deleted the filters, and run at the end, it's fine deleting previous steps.
Yeah, so this doesn't assign to anything, it's just to show it in the console. So if we were to do, this, then GMDF now has the new column GDP saved, so you can't revert back anymore because you overwrote
Okay.
GMDF. You would have to go back up and run this command again. Okay. We have a bunch of columns now. What if we want to see the relationship? Now we're going to do some visualizations and stuff. And I wanted to focus a lot on visualizations this time because we didn't spend a lot of time on it last week, and you can do a ton with that. So we're going to use something called ggplot, which is a user-created package that makes R plots way nicer to look at. Like the base R plot is pretty terrible. So we're going to use ggplot because it's pretty, and I like things with colors. So to do that, you just write ggplot, gmdf, and then mapping equals AES, x equals life expectancy, y equals GDP per cap, and then plus, and then on the second line, geom point. So to step through what this is doing, ggplot is the function, gmdf is the data that you're passing to that function. That's your spreadsheet, your data frame. And then AES are the aesthetics and the sort of specifications of the graph. So you're setting the x-axis here, the x-axis is equal to life expectancy. The y-axis is equal to GDP per capita. And then the plus geom point specifies what type of graph you want. Everything up here is global, and then this is sort of like narrowing down specificity into what sort of graph you want. So if you run this, you'll see this cool graph in the viewer over here. Obviously this doesn't say much at the moment because you can't really see where these countries are from, but we'll get to that in a second. And it's important to note that in ggplot you use a plus sign instead of a pipe. Does everyone see this graph? Anyone having issues? Okay, so if we want to see color, if we want to see, say, the distribution of these by continent, then you can do, up in the aesthetics bit, you can do color equals continent, just like that. And then run it again, and you'll see the colors of the continents in here. Does everyone see something like this? Cool. Again, this doesn't actually show you much because it's just a bunch of points all clumped together. If we want to see, say, the distribution of life expectancy across the countries and see where the highest frequency is. We can make a histogram using the same technique. GMDF. In this case, we only have one variable that we're looking at. We're looking at life expectancy, so we can just do that. X equals life expectancy plus geom histogram. And you can see that most countries fall in the 70s range. This is the variable is country year, so most country years fall in the 70s range. We can also do color again to see where these fall. Color equals continent. Oops, I meant fill equals continent. Change color equals continent to fill equals continent. And you can see, not surprisingly, Europe has a lot of countries in the 70s range. If you want to break this down a little more and see this a little easier without it overlapping and stuff, you can use what's called a frequency polygon count or graph, which is geom, or just delete geom histogram and replace it with geom freq poly, like that. You'll get this. You'll have to change fill to color. This is a little easier to see.
And in case I wanted to know the exact number, so like this is a graph, but if I wanted to know like exactly what is the age, the highest age, you're saying in the range of the 70s, but if I want to know it exactly, how would I know?
So you can do, let me check to see if this works. Max. So you want to actually see which is the max.
Like in general, like this program would help us analyze and create visualizations, but at the end, if I want specific information from this visualization, how would I extract it?
So you have to do that. You have to code it in here. I'm trying to remember how to do max. But you can do.
But it can give me.
Yeah, I can do that for sure. I'm just trying to remember how to do it.
Is it the highest and lowest?
So what's the secret? Where are you getting the functions from? How we can get the functions? Like we will be remembering all these things?
I mean, ultimately, like there are plenty of resources to look this up online. But as you do this more and more, you'll remember things like this. You can also, if you don't remember how a function works,
Yes.
you can do question mark like mutate, and then run this, and it will pop up a help page over here. So you can remember how to do this.
It gives examples.
Yeah. I use this all the time because I constantly forget how things work. If you wanted to find those summary statistics, like say you wanted to find the average per continent for life expectancy, what you can do is this and then group by continent. This group by function groups the data into like containers, and anything you put in there is what I'll group by. So I'm going to group by continent. Then I'm going to do summarize mean life expectancy. So you can see that. I think you can do max. Yeah, you can do max as well. Does that make sense?
Yes.
Cool. Everyone else get that? This is how you do summary statistics for different groups. So if you wanted to find the average per continent or the max per continent, you can do this. And then say you wanted to find the actual country and year that this applied to,
Yes.
that this down here applied to. You can do GMDF, filter, say we wanted to see, like Asia has 82.6 for its highest life expectancy. You can do filter life expectancy equal to 82.6, double equals. And doesn't have anything interesting. 81, let's try.
So
I don't know why this isn't showing up.
maybe it will need to do something like less or more than, like
Yeah,
more than,
let's do
so
that.
it get
Yeah, you can do that too. You can do
yeah. So they
yeah, so there you go. Now you can see
the,
Japan in 2007 has 82.6.
Yeah.
So in filter, you can also do comparisons like less than or equal to, greater than. This is greater than. If you want to do greater than or equal to, you just stick an equal sign there. And this is how you can see like the highest
Yeah.
life expectancies. That's how you get those exact numbers. Any questions on this? The summary stuff? Cool. So going back to visualizations, if we wanted to, like the two variables that people talk a lot about with regards to countries is the relationship between like GDP per capita and life expectancy. So if we wanted to show that, ggplot, GMDF, mapping x equals, let's do GDP per cap on the x, and then y is life expectancy. Plus geom points. So if you wanted to add another, you can add another layer on top of this. So just do after geom point, add plus geom line. And this will actually this won't do anything. Let's do geom smooth. I think that'll work. Yeah. So you can sort of see that, like this geom smooth allows you to see essentially a line of best fit.
On the first line, what's after y?
Since GDP is giant, if you wanted to see probably a better relationship, you can stick a log on GDP per cap. Just do log, open parentheses, GDP per cap, close parentheses, and then comma. And I'll show you a slightly better relationship here, even though it is an exponential relationship. So you wanted to see something that's actually the line of best fit. You can change geon smooth to stat underscore smooth. And then I think it's method equals LM. LM stands for linear model. So it's a linear regression model, and then call it equals red. We'll just make the line of best fit red. So this is the actual line of best fit based on the regression model. What if we wanted to see a bunch of lines of best fit for each continent? You can do that. Just by adding the color equals consonant attribute back in here to the top. Or that'll add one. Well, in any case, you can see the different colors of the consonants here, which gives you a little better idea. Okay, so say you wanted to put this in a paper, this graph. Doesn't look too great right now, but there are ways to modify it. So if you wanted to change the labels, say, you can do lab, or labs for labels, and then title equals GDP, or life expectancy versus GDP per capita. Comma, and then you can add a subtitle if you want. And if you run that, then you'll see that you actually have a title and a subtitle. If you wanted to change the axis labels, you can also do that, just in here again, in the labs, x equals log of GDP per capita, comma, y equals life expectancy. This is going to look terrible down here, so if you want to see the bigger version, you can just click the zoom button and it'll show you a nice big one. Does that look good? I'm not a big fan of the base theme in ggplot. Thankfully, there are dozens of different themes, which is why I had you guys load the library GG themes. If you want to make it look like a Wall Street Journal graph, you can do plus, on the outside of this, after this parenthesis, you can do plus theme underscore WSJ, open close parenthesis. I'll show you this nice thing that doesn't look great on the screen. This text is terrible, but you get the idea. Yeah.
Can you go back a little bit more?
Thank you.
Yes. And to one.
GG Themes also has like a 538 theme in it, which I like a lot. This is my favorite. It looks the nicest. I also like 538, so yeah. If you like stats related to politics or baseball, 538 is the way to go. They definitely nailed the formatting on their graphs too.
It's super cool.
It's so nice to look at.
It's like kind of like a vlog-ish situation.
Yeah. I don't know why this isn't formatted correctly, but yeah, 538 is awesome. You guys should look at it if you have any interest in stats / polling. Like they're usually the best at modeling political predictions. There are tons of these themes. If you want to see more of them, you can do. I'll do it up here. $GG themes, and then run that, and you'll see the description of the package, and then you can go click on this, and it'll take you to a bunch of. If they were better at their documentation, it'll take you to a list of themes that they include. You can click on the GitHub thing. Actually, don't. Their documentation is terrible. But if you have any interest, if you ever don't know what a function does, you can do the function. So you can do $select, $GD plot. It'll bring up the help page over here. It's really useful. I do this all the time. Because I have a terrible memory and can't remember what things do. Continuing with this graph that we're working on, if you wanted to see like how the population is related to the GDP per capita, but you didn't want to use the GDP variable that we created, you can make the size of the points on the graph reflect the population of the country. So up in the aesthetics thing, after the y-axis, you can put size equals pop. And if you run that, and it doesn't get absolutely destroyed, which it might, but you can see that some of the size of the points has changed to reflect the population of the country. That isn't the most informative thing ever. So what you can do to sort of break it apart and see, look at it per continent, you can do what's called facet wrapping, which essentially breaks the graph into multiple graphs and then shows you it all on a grid. So to do that, you can just do facet wrap, and then that character continent, and then remember to put a plus after that. God, this screen is so screwed. You should see something like that. Hopefully it looks better on your screens. I'm going to change the theme to theme minimal, just so it's easier to see. It's a really cool way to visualize this stuff. You can also, in Gapminder, there's a attribute of the data called country colors, which is an assigned variable already in here that assigns a specific unique value to each of the countries, a unique color value to each of the countries. So change color equal to country, and then down here add another line that's scale color, I think this manual values equals country color. Country colors, and then add a plus sign after that. Hopefully it works. Maybe it won't. Oh, yeah, okay, sorry. You have to add another line, that's the value that you're scaling. So scale size range equal to C to 12. And then add a plus sign after that. So these are the two lines we just added. Might not work. Why isn't it working? Oh, there we go. Might look terrible. So we're going to add another line, which is, actually we're going to add, so in here, in geonPoint, in these parentheses, add show.legend equal to false. That just turns off a legend. There's a really cool package that's experimental right now, but I'm not gonna show you it today. But it's called GG Animate, and actually will animate this and turn it into a GIF automatically to show you the progression over time. It's really cool. So, anyone have any questions on this so far? Any questions about what any of these lines do? geonPoint makes a point, scatter plot, stat smooth draws the line of best fit, scale color manual specifies the scale of the color values that you're going to be using, scale size specifies the range of that scale, labs, all of this changes the title, subtitle, X and Y axis labels, facet wrap breaks it into 5 different graphs for each continent, and then theme minimal specifies the theme that you want to use. Cool. I'm going to do one more thing before we end, because you guys possibly might actually need to use this for things. So I'm going to show you how to do linear regression. It only takes 1 line of code, so it shouldn't be too bad. But if we wanted to say, actually find the value of that line of best fit, or find what that line of best fit is doing, how it fits, how significant it is, the relationship, we can do linear regression on this. So what you're going to do is make a variable called model, which will house the linear regression model that you're building. And then do LM, life expectancy, log GDP per cap, and then GMDF. So what this is doing is life expectancy is the dependent variable. This is saying check what it's related to. Is it related to the independent variable GDP per capita? And then GMDF is the data that you have to specify for this.
Can you repeat your explanation one more time?
So LM means linear model. We're doing a linear regression on this. Life expectancy is in the dependent variable slot, so the Y slot. This character right here says, check if this is related to this. So if the left is related to the right. GDP per capita is in the independent variable slot, the X. And then GMDF is the data that we're using, and you have to specify that for this to work. So if you run that line, you'll see a new variable over here. That's your model variable. And if you want to see how it fits, you can do summary model. And down here in the console, you'll see all the results. This is your independent variable. This is your essentially the coefficient estimate. This is how strong the relationship is. So clearly it's very strong. Anything above 1 is really strong. And then this is your p-value. You can see it's extremely significant. This is just a basic statistical model that you can do. If you are like me and never took a formalized stats class before and had very little idea what any of this actually is, essentially what you have to look at is this number under estimate. If it's big, that means there's a strong positive relationship. This number is your significance. If you want it to be small, because that means that the relationship is significant, meaning that it's probably not due to chance. Oops. So this is showing you the same values that that red line does on the graph. It's just a way to see it in numerical form so that you can use it in a paper or whatever you have. So I could keep going on like this for hours and hours and hours, so I'm going to let you guys go right now. But before I do, I'm just going to point out again, there are a ton of different materials online. The best one is called R for Data Science.